in the community that work on the same subject. If you work on a new idea, you get very little feedback very often. And you have to recognize that. That's a mode of your life that you have to accept if you want to break new territories. So in terms of historic trends, there are ideas that belong to venture capital that became stocks and then later became bonds. These are the good examples. For example, the Big Bang. Einstein resisted it early on, but then when data came in, he realized that he needs to accept it. And the data was analyzed by various people. The cosmic microwave background, back when Gamow proposed it and worked on it, it was not regarded very highly. And then Penzias and Wilson discovered it by chance, and now we use it as the best probe of the early conditions in the universe. The dark matter. When Zwicky was working on it, not many other people, partly because of the personality of Zwicky, not many other people were working on it. And then it became very popular. Inflation. I remember when I started my postdoc, people were very critical of it. They were thinking it's a crazy idea. And by now, it seems to be, there seems to be no alternative that is popular at the moment to making the initial perturbations. There are also examples of venture capital ideas that became junk bonds or became, that lost a lot of value. For example, the steady state cosmology. This is the idea that the universe existed forever and there was constant production of matter. Even though the universe is expanding, you replenish the matter that is expanding by new matter, and you end up getting the same state of the universe at all times. This was an idea advocated by very good physicists. And some people even conjecture that Hoyle didn't get the Nobel Prize because he advocated this. But then, of course, once the microwave background was discovered, this idea was abandoned. Topological defects, cosmic strings, just 20 years ago was a popular idea. And then the microwave background anisotropies ruled it out as being the dominant mechanism of producing fluctuations in the universe. There was, a decade ago, there was an idea promoted mainly by Peebles that the dark matter may be baryonic. But we know from the Macho experiment and the microwave background anisotropies that this is not likely to be the case. And there was the suggestion that the X-ray background originates from a hot intergalactic medium, advocated by George Field here. And then there was even an experiment that confirmed it, but then it turned out that the heat from the exhaust of this rocket was responsible for the signal that they detected. And we now know that the X-ray background originates from point sources, mainly. Quintessence is now not very popular, even though it was popular for a while. So there are ideas that lose value. These are ideas that started as venture capital and end up in a wastebasket of ideas. Most ideas are like that. Then there are ideas that become stock for a while. And from there, they can end up also in the wastebasket, or they can end up as bonds. So these are possible trajectories. And you have to recognize that when you invest in either a venture capital idea or in a stock idea. Now, the question is, what is the common investment strategy among postdocs these days? And based on my statistics, on the people that I interact with here, I see about 5% investments in venture capital ideas. On average, this is on average. Of course, any single person may put much more time into any of these categories because some projects require more than 5% of the time. So some people have 100% of the time on venture capital because that's the nature of the project that they work on. It requires a lot of their attention. And 80% among the postdocs that I interact with put their research time into bonds. What is my recommended strategy? On average, average over the community, I would say investment at the level of 20% in venture capital is healthy, 30% in stocks, and 50% in bonds. So I'm not advocating that every person works on some crazy idea that they think on. I do think that we still need to invest a substantial portion of our portfolio in bonds. But we should have also some fraction invested in venture capital ideas. Now, aside from this recommended strategy, I have some other rules that I would like to suggest to young investors. The first rule is avoid second or higher order speculations. Because the probability that a second order speculation is right, and by that I mean a speculation based on an idea on top of an idea that is a speculation, the probability of that being right is the product of the probabilities of each of them being right. And then it becomes very small probability. So I would highly recommend that you invest only in first order speculations. So examples of second order speculations is, for example, Mond, which argues for a modified form of Newtonian gravity. And then people realize that it works perfectly well within galaxies, but when you consider the microwave background, you really need to add some dark matter in order to get it to work. So they added neutrino dark matter, some hidden sector of the neutrinos that provides some form of dark matter. I regard that as second order speculation because not only that you modify gravity in order to avoid dark matter, but then you add dark matter in order to explain all the data. However, among the 100 emails that I received on my posting on the archive, which was more than the total sum of all the responses I got on the 300 or more papers that I put on AstroPH before, among those 100 emails, there was one which was a very aggressive attack on me putting Mond plus neutrino dark matter in this category. Because that person regarded Mond as a viable truth of nature, and therefore it's only a first order speculation in his mind. No. Modi actually accepted my view on this. But often people that subscribe to a theme proposed by others become more religious after it. And there are other examples. You can imagine making black holes as the dark matter at the end of inflation. So not only we don't know what the nature of inflation is, but then you postulate that not only there was inflation, but there was a process that is speculative that ended up producing black holes as the dark matter. And we don't know the nature of the dark matter. And also, there is no reason to worry about non-Gaussianity from cosmic strings because we haven't yet seen the effect of cosmic strings. So we haven't seen the non-Gaussianity either in any of the surveys that were made. The other very important lesson that, in fact, I realized as a result of an interaction that I had with one of my students. So the student, I will not mention names, dedicated maybe 6 months of work to a project. And then when he wrote the paper, I came to him with a question. I said, what about this other possible thing that we should mention in the introduction because it's an obvious thing that could be important, but you haven't mentioned it. Why don't you find the references that cite this possibility? And he looked at the literature and didn't find any paper on this alternative. And then he realized that it's actually a very important possibility. So we ended up putting our attention to this thing that we came across just when we wrote our paper. Then I asked him to give a talk on this at the ITC lunch. And he gave 80% of the talk was on the 6 months that he worked on the other thing. So I came to him afterwards and I said, look, it's irrelevant. It's completely irrelevant that you spent 6 months on something else. We found something important. You should just mention this thing. This is the thing you should focus on. Progress is not linear in time. Forget about the reasons that you started to work on something. That's not relevant. You did your work, you found something else. Just focus on that. Even though you lost a lot of time in the process, you should focus on the new thing that you discovered at the end. That's a very important lesson. Because what matters at the end is what you find, not how much time you spent on it. And you can spend one day, you can go hiking for the rest of your life, and you will still get a Nobel Prize. Okay, so just just focus on the important new results, even if you dedicated a lot of time on the way to something else that became irrelevant. And there are many examples of such accidental discoveries. The microwave background is an example for that, and that's a Nobel Prize. Gravitational lensing, these arcs, beautiful arcs that exist around X-ray clusters. You can go to UpJ volumes that were published well before it was announced that these arcs exist. And you can find those arcs there. It's just that the people that wrote these papers were motivated by something else. And then they saw these arcs and said, well, that's something else. Let's leave it aside. But then these arcs are a major tool for measuring masses of clusters. So what I'm advocating is if you see something unusual, either in your data or in your theoretical research, don't put it aside just because you were aiming at something else. And leave spare time for unexpected discoveries that might change your research plans altogether. Don't make everything predictable. So my main conclusion is actually not only for young people to put time into creative projects, but also to senior people that are sitting on selection committees and promotion committees. They should find ways, new strategies, to reward creativity for the benefit of the field as a whole. And a specific example is for NSF to allocate a small portion of its funds to projects that are out of the mainstream. They don't do that. That's my sense. And among the emails that I received, it was the sense of the people that wrote me these emails.
Several years, NSF has tried at least to impose on the program officers that they should.
Well, if they did, then it's good, but I haven't seen direct...
I don't know what they've actually done, but that was the intention.
Okay. Well, the important thing is not just to have... they say that the road to hell is paved by good intentions.
I understand.
To make sure that it happens.
Don't conclude that my ignorance implies that they haven't done it. I just don't know that they have.
I think it boils down to people that serve on the committees because the NSF administrators cannot really evaluate the value of a scientific proposal. And my call is for the senior people in the community to pay more attention to out of the mainstream project.
You should go work at the NSF for a few years.
I want to make some discoveries, not be an administrator. And then for those that take the roads not taken, keep your spirits high. Because my view is that there is no other point to doing science than taking roads that were not taken by others. And for that, I use the quote from the poem by Robert Frost, The Road Not Taken. Two roads diverged in a wood. I took the one less traveled by, and that has made all the difference. Thank you.